All right, today we are digging into a really fascinating new AI model called EchoX. And, it's tackling one of the biggest, most stubborn problems in all of voice technology, and its solution is, well, it's just incredibly clever. So let's get right into it. I mean, it's a question we've all asked ourselves, right? We've got these text-based AIs that can write poetry, that can plan your entire vacation, even explain quantum physics. But then you turn around and you ask your voice assistant a kind of complex, multi-step question, and it just falls flat. So what's going on here? Why the huge gap? And the difference is just night and day. On one hand, you have text models that feel like you're talking to a brilliant expert. And on the other, you have speech assistants that can feel more like you're just typing commands into a terminal. There's actually a name for this problem. It's called intelligence degradation. The smarts just don't seem to make the jump from text to speech. So here's how we're going to break it all down. First, we'll look at this AI intelligence gap. Then we'll get into the real culprit, the conflict between sound and meaning. We'll see XX's really smart solution, how it's trained, how well it actually performs, and finally, what all of this means for the future of voice. Okay, first up, the AI intelligence gap. Let's really get to the bottom of why these talking AIs seem to be losing a few IQ points along the way. So here's the formal definition, but what it really means is this. When you take a super powerful text-based AI brain and try to teach it how to actually speak, something important gets lost in translation. All that knowledge, all that reasoning, all that nuance, it just degrades. The AI literally becomes less smart, just because it's trying to deal with sound instead of text. And that brings us to our prime suspect in this whole mystery, this fundamental, deep-seated conflict between understanding sound and understanding meaning. This is the absolute heart of the problem. Researchers call it the acoustic-semantic gap. And I want you to picture a tug-of-war happening inside the AI's mind. On one end of the rope, you have semantics. That's the meaning of the words. On the other end, you have acoustics, the literal sound of those words, and they are pulling in completely opposite directions. So let's break that down. A text model, you see, it's rewarded for understanding meaning. So if you're training it and the right answer is hello, but the model says hi, that's great. Hi means basically the same thing as hello. The model gets a point for understanding the concept.
But for a speech model, oh, it's a totally different ballgame. The actual sound waves for hi are nothing like the sound waves for hello. And because that speech model is being judged on matching the sound exactly, it gets a massive penalty for saying hi, even though it's a perfectly smart and correct answer in terms of meaning.
So you see the problem? This whole situation forces the AI into an impossible choice. It has to choose, do I sound right or do I act smart? And for a long time, in the race to get perfect, clear audio, intelligence is what got sacrificed. And this is exactly where EchoX comes in and just changes the game completely. It's designed from the ground up to bridge that gap, to make it so the AI doesn't have to choose anymore. The researchers put it perfectly here. Instead of making the model choose, EchoX connects the two worlds. Basically, it uses its own understanding of meaning, its internal thought, to generate its own audio target on the fly. It learns to connect what it wants to say with how it's supposed to sound. So, how in the world do they actually do this? It's a really elegant three-stage training process. Let's take a look at how EchoX learns to think before it speaks. Okay, so stage one is pretty basic. Listen to speech, write out the text. Stage two is also pretty standard. Take text, turn it into the building blocks of sound. But stage three, echo training, this is where the magic happens. The model comes up with a thought, an internal idea, and then it feeds that thought into the stage two module to hear what its own idea sounds like. It's literally creating its own perfect, semantically correct audio to learn from. It's learning to align meaning and sound from the inside out. It's brilliant. And they have another trick up their sleeve. See, raw audio data is really long and clunky for an AI to process. So EchoX uses something called unit language, which basically compresses bits of sound into these neat word-like tokens. The result? The audio sequence is more than twice as short, which makes the entire learning process way faster and much more efficient. Okay, so it's a clever design for sure, but does it actually work? Well, let's get to the results, because this is where things get really, really impressive. Get this. To achieve everything it does, EchoX was trained on just over 6,000 hours of audio. Now, in the world of big AI, that's practically nothing. And that's the context that makes this so incredible. The big competing models, the giants in the space, they are often trained on millions of hours of data. EchoX is getting these amazing results with just a tiny, tiny fraction of the resources. It just goes to show how much more efficient its method is. And here's the proof. On a standard test for knowledge-based questions, EchoX is performing right up there with models that were built with vastly more data. It is the classic underdog story. It proves that a smarter training method can absolutely beat brute force. So, let's wrap this up by taking a step back and looking at the bigger picture. Why does a breakthrough like this actually matter for all of us? Well, here are the big takeaways. First, EchoX gives us a real solution to that sound versus meaning problem that's been holding speech AI back for so long. Second, it shows that you can get top-tier performance with so much less data, which makes building powerful AI way more accessible. And what that means for us is that this paves the way for voice assistants that aren't just taking commands, but are true, intelligent, conversational partners that actually understand context. And that kind of leaves us with one final big thought. For years, we've been trying to get our machines to talk. XLX is a huge step in getting them to think before they speak. So the question isn't just can they talk anymore, it's what will they have to say, and what happens when our technology can finally truly speak its mind.